I don't know, but I teach fifth hour too, so that way I just have it. Then we have something called a conjunction. There's a conjunction in math class, isn't there? Or in English class. What's conjunction mean in English class? And, but, or, right? Are those conjunctions?
Conjunction, what's your function?
So you can kind of use that to help you remember what this means, but kind of not, because conjunction means when you're saying this and that, right? So that kind of means like at the same time. That's what the and part means, and it has its special little notation in math class. It looks like a triangle. I remember that it kind of looks like an A without the middle line, so that's how I remember that it looks like that. For and, P and Q.
Aha.
See what I did there?
No A. I said C. I said no.
So this is where the English part doesn't fit with math class, because we also have something called a disjunction. And a disjunction is a compound statement formed by joining two or more statements using the word or. So the difference between and or, if I said I'm eating chicken and fish for dinner, that means I'm eating both. If I say I'm eating chicken or fish, I'm doing one or the other. Does that make sense? Kind of.
Okay, now.
So and is like at the same time, or is separate. If you think about inequality, remember in algebra, an and inequality like meets in the middle and an or goes in opposite directions? Remember that? That's another way of thinking about ands and ors. So the notation is or is an upside down A. So it's not I always remember that one looks like an A and that one's the other way. And you read that as P or Q, not PVQ. It's not a V. It's an or statement.
You should mind your P's or Q's.
We also you don't have to write this down, but outside of geometry class, when we're not talking about proofs, it's also made like this, like it's curvy. That's also read P and Q, and also it's like a U like that. P, U, meaning like union or intersection. So that's another also known thing in math class. Okay?
If you write P or Q without the spaces, it spells poor.
So the only thing, if you look at section 2.2, there's all these crazy tables that they want you to make these truth tables where you fill in lots of truths and falses, and it's kind of silly. There's not a standard that goes with it, so we're not going to work on the truth tables because I think it's silly. But what we are going to do is something that I think is worthwhile, is talking about Venn diagrams, which I know you've seen before. And we can talk about and or, like what is the difference between it? And if you're talking about a story problem, they're not really going to use those P's and Q's, but we can kind of write it out that way if you want. But it says the Venn diagram shows the number of students enrolled in Monique's dance class for tap, jazz, ballet. Oh, for tap, jazz, and ballet classes. So Venn diagrams, 2, you see 2 a lot. 3, right? Anywhere they're overlapping, that's where they're doing both, right? So if it says how many students are enrolled in all 3 classes, what would the answer to that be? 9, because where all 3 circles overlap is 9. Do you agree with that? That's not bad. Doesn't even feel like math, right?
Can we just have like everything be like this? What's in the middle?
So notice this one says how many students are enrolled in tap or ballet. So I want to know all the tap or all the ballet. So tap, do you agree that that would be 28? That's the number we need. What else do we need? We definitely need 29. I think we need 17 too. Do you agree with that, or you don't agree with that? Audrey?
Well, because that's how many are in both of them. So that means they're already.
Answer B 28.
Are they already?
They're not included. So 28 represents just how many are only taking tap. Does that make sense? 13 are taking tap and jazz at the same time. 13 are doing that. So the number out here is not included in those. Does that make sense? So if we wanted to add up how many total people are enrolled here, do you agree you'd have to add up every single number? Because none of those are counted already. Okay, so here's what I want you to think about or. Or means I want all the people in tap, even if they're in more than one thing. I want all of them in tap. I also want all of them that are in ballet, even if they're in more than one thing. But I don't want them if they're not in either tap or ballet. So what number don't I want to count? Eric says 43. 43 we're not going to count because are any of those people in tap or ballet? But if you pick any of these other numbers, are they in one of the other? Are they in tap or they're in ballet? So when I think of or, I think I want all the tap, all the ballet, and I'm going to put them together.
That's a lot of numbers.
It is a lot of numbers. So basically we want everything but 43. So if we knew how many total there were, we could just subtract 43. But I think we should say, like I could write this. I could write T for tap, and or is upside down. B for ballet. I'm going to try to use our notation here. And I'm going to add up 28 plus 13 plus 9 plus 17 plus 25 plus 29. What's that equal? Like 105? I'm making that up.
Can we just like leave that as it is?
You can add it up. Oh, 121, I'll tell you. You can have a calculator on a real problem. But it's 121. This is a lot of kids.
Come on, kid.
So look how C is different than B. Because on B, we just wanted tap or ballet. But on C, we want them that are in jazz and ballet. So that means they have to be in both. But we don't want them if they're in tap. So looking at this picture, where is the overlap of jazz and ballet?
25. Green thing.
9 is also overlapping, but why aren't we counting 9?
It's also in tap.
Did you have a question, or you were just trying to be nice and wave your hand? Those kids in front of you are just going to slap them in the back of the head. I think for C, we just say 25. Because and means they have to be in both at the same time, but or means I can take tap, or I can take ballet. So I have one question on your homework with a Venn diagram, just because I think that's the kind of question that shows up on those standardized tests sometimes. Worthwhile to talk about. All right, but that's all we're doing from section 2.2. That's it. So if you turn the page here, I guess I should label this. We should call this section 2.3 at the top. I lost my book. I don't even remember what section 2.3 is called. It's then, I think.
Math.
So which one's harder?
Hard math.
2.2, is it a video? Not believe
I think
Oh, it's called conditional statements. There you go. You could just do this. 2.3. It's called conditional statements.
No.
Guys, Taylor, do you need to move?
No.
One year I had a student every day because they couldn't keep their hands to themselves. Every day they would come into class and we'd move their chair up right here and they'd sit right here.
It'd be really inconvenient.
Can I face the class?
So be good. We can do this.
Short, you don't want one of those?
This is the dunce chair.
That's like a straight line this way.
She what?
Even one way.
Okay, there's a lot of vocab here, a lot of symbols, all right? But this stuff's really important, all right? Every time you see a rule in math, a theorem, a property, they always write it as a conditional statement. And a conditional statement is one that we say is in the if-then format. So an if-then statement is what we're going to see over and over again. And so, again, we're using lots of P's and Q's here. I don't know why they use P's and Q's, but they always do. But the symbols here, you use an arrow, P, arrow, Q, and you read that. If P, then Q. Or it implies that P implies Q. The nice thing with math, we have a lot of symbols. We don't like to write words out. Unfortunately, I'm teaching you all those symbols, so that's why there's lots of words to go with it. But eventually, we can use the symbols. So the if part of that statement is called the hypothesis. If this is true, right, and that kind of makes sense. Think about what you talk about a hypothesis in science class. The if this happens. And it's always after the word if it's already written in that format. If this is true, then the then part is called the conclusion. Or I guess we should say the hypothesis is the P, the conclusion is the Q. I don't really know why they modeled this here, but they're modeling that P has to be true in order for Q has to be true. I've never used that picture before in my life, but it's on the table. So.
Will they always be P and Q?
Well, they're going to be we're gonna see things today that say, I was just reading one last hour that says like, if today is Monday, then tomorrow is Tuesday. And then you have to say, is that true or false, right?
I hope it's
Or what's the hypothesis, what's the conclusion? And it seems kind of silly, like people always say, how is this math? But when you see a theorem that says, if x is a real number, then this is true, you have, the if part's really important. In calculus, we have all these theorems that say, if on the interval from a to b is a continuous function, then we can say this is true. And it's important to kind of understand what that means in order to know what those theorems mean later on. So that's kind of what the focus is before we can get to the proofs. Okay. So part of your homework today is just identifying the hypothesis and the conclusion, and sometimes you have to put it in if-then form because it's not in if-then form. So look at A here. It says identify the hypothesis and the conclusion of the following statement. If a polygon has 6 sides, then it is a hexagon. What is the hypothesis? Yeah, it's, don't use the if part. It's what's after if. So it's nice I printed it for you. You have to write it, right? A polygon has 6 sides is our hypothesis. I'm going to say HYP if you're okay with that. Oh yeah, for P and Q, I'd be okay with that. Then it is a hexagon. What's the conclusion? It is a hexagon. Conclusion. Or I like the P and the Q. That's a good idea. On your homework, you actually have to write it out because it's not printed out for you, right? That's pretty easy if it's in if-then form. But look at the second one. Tamika will advance to the next level of play if she completes the maze in her computer game. What is the hypothesis in that statement? Garrett. Yeah, if we were going to put this in if-then format, the she completes the maze in her computer game would be the if part. If she completes the maze in her computer game, then we would say what? Yeah, so it's not always in the right form. You have to think about how you would write it. So we're going to say here, P would be she completes the maze in her computer game. Then the conclusion, Q, would be, and you could say, like when I wrote this on my paper, I said she. We could say Tamika, I guess. Tamika will advance to the next level. See what I mean about writing in that fast? I feel about that. Overjoyed? Alright, let's see. I might have a one on your computer now. I don't know. Oh, look, I do. I don't know where.
If you're a big.
If you're a baby, then you will cry. Do we want to use a computer, or we want to just do like raise our hand? We could do like raise your right hand if it's A, raise your left hand if it's B.
Both hands if it's C.
Both hands if it's C.
Both hands
Stand up.
open. Or
Stand up if it's D. How about that? Oh my gosh, that's really confusing. So this is right hand, left hand, both hands, stand up.
slow down.
Let's read it. Which is the hypothesis of which conclusion? If you're a baby, then you'll cry.
Wait, alright.
Left hand, B. Do you agree with B? B.
So,
See what I mean by it's not math? That's just silly.
babies
Babies cry. You are a baby. So, here's why order matters, and we're going to talk about this in a minute. If you switched around, if you say, if you cry, then you are a baby, is that true? I mean, I guess if you want to call people that cry babies, but like, that's not always true, right? But if you're a baby, then you will cry. Yeah, I think all babies cry. I think we would say that's true. So that's why it matters which one's first, okay? Okay. Okay, I think you have this one on there. So here's where it gets a little trickier. What if they don't have the word if or then in there? Could you make this into an if-then statement? So it says, identify the hypothesis and the conclusion of the statement, and then write it in the if-then form. For me, it's easier to write it in the if-then form and then state the hypothesis and the conclusion. But you just have to think about how would you take this sentence, measured distance is positive, and change it to an if something, then something. And so sometimes you have to add some extra words in there, and the more you do this, the better you get at it. So does anybody want to take a stab at this one, or do you want me to do it? Audrey, what do you think?
It's saying if it was a measured distance, then it is positive.
I think that would work. If it is a measured distance, then it is positive. I think I said if a distance is measured, then it is positive. That would work too, right? So there's kind of some variation that works there, but I'll use yours. If it is a measured distance, then it is positive, or it will be positive. Right? That's a little bit trickier than the last one. And so if you write it in that format, then it's easy to say. You can just kind of underline it and say hypothesis, or I really like Grace's P, then Q is the conclusion. How about a five-sided polygon is a pentagon? That's very true.
I put if it's a five-sided polygon, then it is a pentagon.
That works. Could, yeah. Okay. If it is not really sure what's happening.
Oh no, it's black. Oh no.
I'm excited.
If it is, you find.
Polygon.
Go 5.
Then
5.
it's
It just says, if it is,
wow.
you fire.
It's
What? Fire-sided polygon.
pentagon.
Your
That's
key is
weird.
Fire.
color.
It is a five-sided polygon would be our hypothesis. Oh, look, I switched back. It is a pentagon would be our conclusion. Could you say, if it is a pentagon, then it is a five-sided polygon? You could say that too, right? And then there, depending on what hypothesis and conclusion is, changes, but that's still a true statement. So, okay, let's see if I have one for you too.
Are you sure it's not?
Oh, look, I do. So let's do, we'll just do this again. Right, left, both, up. So stand up means that one. Which of the following is in the if-then form of the given statement? A polygon with 8 sides is an octagon.
That.
Oh, right. Are you saying B?
Yeah.
B. You could argue C, right?
Yeah.
But I think going with the order of that sentence, they're saying B is the best answer
Because it's like in
because it says a polygon with 8 sides. That's true. If a polygon is an octagon, it does have 8 sides, like we were talking about. But I think they're going with saying the order of that sentence.
A could also
you
be
could like
true.
put the one stand in it.
Right, but that's not what that is. So yeah, I'm with you on that. That's kind of tricky. Okay, moving on. See how nice it is that I can print this out. Think how long we would be doing this if we were writing all this. Determine the truth value of the conditional statement. That means what is there in the if-then format isn't true. If this, then this. Is that a true statement? If it's false, give a counterexample. So tell me why it's false. So I got 3 of them here, right? So I don't know if we want to, I don't know how you want to number these. So the first one is a math. That's the hardest one. So we can skip that one first if you want. It's a math one. Look at number 2. If last month was February, then this month is March. Last month was February, this month is March. That's true, right? True.
True story.
If yesterday was Tuesday, then today is Monday. Not true. So, if yesterday was Tuesday, so I'm going to say yesterday, Tuesday means today is Wednesday. See what I mean about how you say, like, if you show this to your parents, they'll be like, how is this math? Like, that's what happens in this chapter every time. But sometimes it's easier to do non-math examples in order to do the math examples. Because now look at this. It says, if you subtract a whole number from another whole number, the result is also a whole number. So step one is, what's a whole number?
Negative 1, 0, 1.
I disagree. Those are integers.
Okay, 1, 2, 3.
Right. Whole numbers don't include negatives. Whole numbers are like the numbers you learned about before negatives. So like starting with 0 and going up, no fractions, no decimals. Okay, so that's important to know because it changes the answer.
So, maybe have like 2 minus 9.
2 and 9 are whole numbers, but when you subtract 2 minus 9, you get a negative number, and a negative number is not a whole number. So this is a false statement. I do want to say here, I did not include this next example, because it was terrible and I thought it's the dumbest thing ever. But I feel obligated to tell you about it, okay? It's not on your thing. I'm actually going to just say it right now because I feel like you're going to just revolt against me when I say this. But maybe it'll make sense to you. But to me, I'm very angry about it. It says, so here's the thing. If a square has 3 sides, then it is a triangle. What do you think about that? Do you think it's true or you think it's false?
That's true.
Gary, you're here first. What do you think? What do you think, Audrey?
Oh, I was gonna say it's false.
I wanted to say it's false,
I think it's
I say it's
technically
true.
true.
but I mean, here's what the rule is in the book, and I'm not going to give you ones like this on the test because I just think it's just weird. But here's the rule. They said if the hypothesis is false, because a square can't have 3 sides, yes?
Yeah.
If a hypothesis is false, then that means the answer is always true.
What?
Right? I'm telling you, I agree with you. It's why I didn't put the example on here.
That makes me
Wait,
mad.
but what if it says if a square has 3 sides, then it is a octagon?
It says no matter what. Here, let me just read this to you.
This class just crossed the line.
I know. It says when the hypothesis. Wait, here we go. Dang it, where did that go?
Can we get a 10, like, on our stuff that's what it's gonna ask us? We're going
The hypothesis is false. A conditional statement. I swear that says in my notes over there it said true, but this says false. That makes me feel much better. It's false. That makes me feel much better. A conditional statement with a false hypothesis is always
false.
false. Okay, my life is complete now. I feel like I don't have to give up on geometry because I was ready to walk away yesterday when my PowerPoint said true. And I was like, I can't do this. And I went to Mrs. Sumter and she's like, I'm not there yet. I don't even know what you're talking about.
How are you not there yet? What?
Third day behind us.
Are we there yet?
False. Okay.
That's a
What are you doing?
Oh my god.
What's happening?
Okay, I'm okay with this now. If the hypothesis is false, then it's always false. Whew, I'm glad we talked about it.
So if the example was true, we just wouldn't take this class anymore?
I think we would just walk away from it. Like, we would
Alright.
just walk away. That's where I was yesterday.
Or
I
if
feel
it's
good.
Say this example's true.
Alright,
then
class, what is 5 times 2?
Okay, are we ready for this? Is this what's next on your paper?
Yeah.
Okay, this is really, really important. The way you write these conditional statements changes the truth value, okay? So if you have a if statement, then statement, so I'm going to use this example here, and we're going to write all these out. If the measure of angle A is 35, then then angle A is an acute angle. That's true. You agree with that? Yes. So, new words. The converse, no, not the shoe.
Conversation.
The converse of a conditional statement is made by exchanging the hypothesis and the conclusion. So switch it around. What would this statement say if I switched the hypothesis and the conclusion? Garrett. No, you still keep the if and the then part. You just change the words that are next to it, right? It still starts if this, then this. You see what I'm saying? If angle A is an acute angle, then exactly right.
That's what I did with the octagon, hexagon, and all that. So I'm not supposed to do that in one.
Unless it says find the converse. So converse is when you switch the hypothesis and the conclusion, which means now it's going to say Q implies P. Notice, oh, I'll let you write, sorry. I'm just so excited. I'm so excited that that was true now. I mean false. I don't even know what I'm saying anymore. Do you agree that this is true? If the measure of angle A is 35, then angle A is an acute angle. That's true. Is this true? If the measure of angle A is an acute angle, then measure of angle A is 35? Could it be something else besides 35? Yeah. So that means that's a false statement now, because it could be 40 degrees, right? That would be the counterexample. So the truth value changes sometimes depending on, sometimes it's still true, sometimes it's not. So converse, you have to know, converse means switch the hypothesis and conclusion. All right, the inverse, which kind of makes sense if you think about additions, inverse is subtraction. The inverse is when you just negate both of them. So you do that negation in front of P and Q. So we say, if not P, then not Q.
That makes sense.
So, here to the last one, let's someone else that. Going with my original one, if the measure of angle A is 35, then angle A is an acute angle, what would not P implies not Q say? Audrey, what do you think?
If the measure of angle is not an acute angle, then wait.
Oh, wait. We're negating the original one now, so skip this one.
Okay. So if the measure of angle A is not 35, then angle A is not an acute angle.
Exactly what that says. I know that's not much room to write all that in.
Very small, and the handwriting will get perfect.
If the measure of angle A is not 35, then angle A is not an acute angle. Is that true?
Not always.
Not always. I think we have to say false on that too. Because it could be any. Son of a gun.
Hey, look, answers.
Oh my gosh. Oh my gosh. Oh, you know my tricks now. What is happening with my smartboard is the real question.
What? Made by birds. Okay, smart.
Okay.
Papa smart. Yeah.
The last one is called the contrapositive. Look at that weird word.
Contrapositive.
Contrapositive is when you negate the inverse. A converse. Contrapositive is when you take the converse and you negate it. Remember, you can remember because they both have con in front of them. I'll show you what I do in a minute, how I used to do this. I don't like this order. This is how the book ordered it. I always do inverse, converse, then contrapositive, because inverse, you just put negative in it. Converse, you switch them around. Contrapositive, you negate that you just switched around.
Okay.
So that's my order that I do. So if we have, if Q then P, what would the negation of that be? Sorry, that's not Q then not P.
Q isn't P. Search my brain. The Illuminati is not from.
So if angle A is not an acute angle, then the measure of angle A is not 35. Is that what that's going to say?
We must learn to keep. What's wrong there?
Looks like you gotta sneeze.
What do you think about contrapositive? Is that true?
Right.
If angle A is not an acute angle, then the measure of angle A is not 35. I think that has to be true, because if it's not acute, there's no way it could be 35. If it's not acute, that means it's either right or it's obtuse. So that means that it's not 35, so that's true. If it's not acute, then it's not 35. I say that's true. Sometimes your brain hurts.
My brain hurts whenever it's in pain.
So there's this thing called logically equivalent, which makes it sound like it just makes sense, right? So let's look at this and then we'll see if it logically makes sense. Logically equivalent just means their truth value and it's contrapositive are always going to be the same thing. They're either both going to be true or they're both going to be false. Look at our example up there. Was our original statement and our contrapositive the same truth value? So, if P then Q will always be the same as if not Q then not P. Notice for us they were both true. If this is false, that means your contrapositive will also be false. And so that's a nice way to check your answer if you know that, if you can remember it. And also, I think we can say that the converse, you could always just put converse equals inverse if you're going to write less of this. Converse and inverse will always have the same truth value. They'll either both be true or they'll both be false. So if Q then P will always be the same truth value as if not P then not Q. This is a lot to remember. Like, I'll put some Quizlet cards on there. I'll try to do that tonight. I'm not promising, but soon I'll put them on there. Of practicing what these mean on there, or just making your own, making sure you know these words by the time we have a test. It's kind of important. Good news is I think I just had one more example and then one maybe for you to do somewhere.
Maths are not perfect.
I know. It's maybe why people struggle teaching geometry is because it's so much not math. It just makes us feel uncomfortable. But it's all about that.
Even if it's not math, it's still mechanics.
What was your uniform?
I mean,
I still don't like it.
Being violent circle? We don't know.
Okay, so I like that they put all this information over
math
here.
are not right there.
So it says, write the converse, the inverse, and the contrapositive of the following true statement. Determine the truth value of each statement. If it's false, give a counterexample. I think step one is we should write this in the if-then form. It's going to make life easier, right? So, bats are animals that can fly.
Yes, maths are animals.
If bats can fly, then they are animals.
How about if an animal is a bat, then it can fly? Does that sound okay?
Oh, yeah.
I think bats and animals have to stay together in the hypothesis for this. So I'm going to say, if an animal is a bat,
What if it's a bat with no wings?
Then you hit
In the counterexample, that's false. Then it is a
Then-
bat.
it can fly.
If it's an animal, fly, then it's a bat.
And notice they ask for some, they give you this as, as some information. Bats are not birds, they are mammals. Bats have modified hands and arms that serve as wings. They are the only mammals that can fly. Who knew that? I'm going to do this in the order that I always do. I always do the inverse first.
Parrot can fly, like depending on how hard we throw it.
Inverse is when you just do the not P, not Q.
So if an animal is not a bat, then
Like
it
in
can't
bat,
fly.
it's an
If an animal is not a bat, then it cannot fly. I should have had this typed so I could just push it and it appeared, right?
It's both fly and bat.
It is not a bat.
Fly is not an animal, it's a bat.
Then
Oh my god. Wait, what do you put after it? I thought you wrote in your order. I was like,
it can't fly. We want to talk about the truth statement of this, or we want to just write them all and then talk about the truth statements?
well, that one's false.
They told us this is true. If an animal is not a bat, then it can't fly.
What other animal can fly? That's true. There's no other. Yeah,
Like
that's
me, I wrote bat.
I think that's true. Do you think that's
I
true?
think it's true.
If a bat cannot fly, then it's
No.
an animal.
But if an animal is not a bat,
Yeah.
so that's the part.
It's fly, that's an animal. Birds are animals too. It doesn't say mammal, it says animal. Yeah.
That's
a
a
word
pretty
of an
similar word.
Animal is such a funny word.
We're animals.
All right.
Animals.
False. Birds can fly. That's what we're saying.
But animals that are mammals.
But an animal is more than a mammal.
But animal.
An animal's anything that's like a talk.
Isn't that yogurt called animal sometimes?
You guys are out of control.
For animals, no, animals are like animals.
Right, we learned to live like animals.
All right, inverse, you do the not. Converse, you switch them around. So what would it say? If, and so what are we saying if? What is if? If an animal can fly, then it's a bat?
If it cannot fly,
I think
Audio this to someone.
it is standing for animal. Do you agree with that?
Yeah.
So I'm gonna say if an animal can fly, then it is a bat.
animal cannot fly.
Really?
If an animal can fly,
If an animal cannot fly,
then it is a bat. Someone said that's false. Give me a counterexample. False. Birds can fly. We said on the last thing that inverse and converse are logically equivalent. They should be both false. So that's a good thing to check.
Crackle pop.
Okay, birds are penguins. And ostriches.
Eagle, you could just get a specific bird. And then the last one is contrapositive.
A lot of birds.
I thought it was emu.
Contrapositive is when you negate this.
Or the
So you're going to add not in there, right? Children. Guys.
Sorry.
If an animal can't fly, then it is not a bat. Right? Do you agree with that?
I mean,
We're gonna be talking about bats for weeks.
go watch the
At least I am. And it's gonna be really fun.
I feel like we just put not in there, right?
What?
I think people struggle the most with this because it's a double negative, right?
Animal can't fly. It isn't bad.
Bad. Smack it out of the sky. Like the hammer of Thor.
I say this is true because if it can't fly and we know bats fly, then it can't be a bat. All right, so you have to kind of think about the if part going to the then part. So if it can't fly, it can't be a bat. So that's true. People struggle with it because it's a double negative. Like we don't normally deal with double negative that often.
All of you.
Oh, okay. Write the converse, inverse, and contrapositive of this statement. The sum of the measures of two complementary angles is 90. Step 1, you have to write it in the if-then format. Maybe. I don't know.
Right?
You can type them if you want. Hold on, and we'll come back to it. Let's figure out where to go.
If an eagle can't fly, then it's a bat.
So go to go formative. Maybe. Maybe not. Why is this not working? Patience. I don't have the patience.
Is that really true? I know that.
No.
You know, if you take over 4 minutes, almost. My nose is gonna like fall.
Alright, you should just be writing this on paper this time.
LMNO. Yesterday, Andrew was like, get out of the way.
Not as good as bats.
If an eagle can't fly, it's not a bat. If a bat, it's a bat.
How much back in the bat?
type this code in.
Socrates.
I know, I'm switching up on you.
What
Don't focus,
will
I'm slow.
you
How?
dot
It's
Right?
www.socrative.com. Type in that code, and I want you to write the inverse, converse, and contrapositive of this. Maybe we should do if then together first, though. If the sum of the measures. So how would we write this? If the measure. What do you think we should write? I feel like we need to break this up a little bit.
K, Q,
What do
D,
you?
J, G,
Hey, where did you go? Well, what's wrong with this?
U, K, K.
no one was on typing.
K, Q, D, G, J, U, K, K.
You can just write it though. You can type it. It's so much easier. We should write if then first, right? Let's do that together, so that we can all have the same if then.
If McDonald's is in America,
If two angles are complementary, then their sum is 90. Do you feel like that's like I feel like you have to kind of break this one up, because you can't really say if the sum of the measures of two complementary angles is 90, then what are you gonna say after that? Like I think you have to say like if two angles are complementary, then their sum is 90. Are complementary, then
they have really big faces.
Oh my god.
It's like
then the sum is 90. The sum of the two angles. I'm just shortening that up. All right. So that's what I think your if then statement should be. I want you to write inverse, converse, and contrapositive, and say true or false.
some. Gonna guess the company having.
I'm gonna double page this so I can. So give me a second. I'll print this out. Give me 1 second. I promise. I'll come back to you.
You said inverse,
Inverse, converse, contrapositive, just like the last example. Oh well. It's not the attitude to have. Yeah. On what? Oh yes, you're supposed to say true or false. It's fine.
what if you didn't?
You failed. It's really not for a grade. It's okay.
Give me the little fan.
It's a check for understanding. I'm gonna give you like 2 more minutes to see where we are, and then I'm gonna show you what I got. You're supposed to do inverse, converse, and contrapositive. Oh, it doesn't say true or false, right?
Yeah.
So it's okay. You didn't fail. I take it back.
I'm not gonna.
But we're gonna talk about it.
I feel that. All of those.
You didn't actually write them out.
No.
Write the converse, inverse, and contrapositive. Garrett.
It even. Have you noticed that whenever you type in the zero, there's a little dot in the middle?
Yeah, that's an
Oh, dude, that's cool. What about no? Nope, not no. Zero.
We about ready? noise.
A little bit. Buster's was on that show.
Oh, look at all these lovely things I'm seeing.
We don't see.
I know, I see them. They're hidden from you. 9 answers.
My answer is one of them.
Is that true? If 2 angles are complementary, then their sum is 90? That's true.
Huh.
What does inverse need to do?
Inverse be like, not P.
Oh, let me touch it because it's on. Oh, awesome.
Julie, say what's going on right here.
Inverse is when you negate both of them. So if 2 angles are not complementary, then their sum is not 90. True or false? True. Converse, you switch it around. If the sum of 2 angles is 90, then they are complementary angles. True or false? True. Contrapositive, negate that. If the sum of 2 angles is not 90, then they are not complementary angles. True. We're going to talk about tomorrow that there's this thing called an if and only if statement. And if it's true both forwards and backwards, so if the inverse, if the converse and the conditional statement are true, then all of those would be true, and you can actually write it in a different way. So, yeah, that's true. It's a definition. It's true. Learn these words, okay? So if you're not finished yet, you can kind of finish it up. Oh. Is your homework, did I put your homework on your paper? Here's your homework. So on page 101, you're going to do number 10. It's a Venn diagram problem. And then on page 109 to 110, you're going to do the rest of these problems. So make sure you write it down. But yeah, you can sign off. If you want to leave your computer here for next hour, you can. If you want to put it back up, you can do that too.
Whoa. That's like one of those gates. I go up and down. Wait, over.
Oh. That was for that purpose. That's okay.